as you already know, my name is JoaoHackerott. I'm doing my PhD with the WRF system in University of São Paulo of Brazil. And now I'm going to follow the presentations with the post-processing part of models. So Olaf will present you about pre-processing and about the physics. And now I'll give you an overview about softwares we can use to evaluate the model output and make the plots. And I'm not going in details about all these softwares, but I would like to show you which tools exist for playing with the WRF output. So, like Olaf told, this is the whole WRF system, and I'm going to talk about the post-processing and visualization tools. So the Vapor, NCL, the GRADS, what is this software and what we should do with which one. First, about the WRF output. The WRF output, the default is a NetCDF file. What is a NetCDF file? It's a binary file that you can manage. You can work with the. It's easy to plot and everything. So it's for creation, access, and sharing array-oriented scientific data. And almost all scientific programs, they support the NetCDF files, which are the .nc files. So whenever you see a .nc file, it's a NetCDF file, and you can open with R, with MATLAB, Ferret, Python, and the next tools that I'm going to show you. The best tools that I like most to work with NetCDF files is this one. For an easy display is the NC View. For making 2D plots, the NCL program or the GRADS. And 3D plots is the Vapor. And to work with the files, I will explain better later. We have the CDO and also NCO and GRADS, and also if nothing happens, you can use Fortran to work with them. All of them, you can open these files. So I'll start talking about the NCL, which is it's a very important language it's not a language, but a software to learn, to use to make beautiful graphics. The NCL, they have a lot of resources in their web page. So if you go in the internet, www.ncl.ucar.edu, you'll find a lot of information in their web page. And it's quite easy to install. You can do both by just type in if you have an Ubuntu, Linux, it's just apt-get install NCL, or you download the binary files from the resource. Here, if you go there, they explain how to install the current version, download and install. And with the NCL graphics, you can do like nice. Most of when we read a paper, a scientific paper with WRF output, most of those beautiful pictures are built with NCL. And we have a lot of examples in the web page. So if you want to make a track of a hurricane, they have examples. If you want to make, for example, a picture with three y-axis, like in Excel, you cannot do it. In MATLAB, it's really hard to do it. You have to write a script, a huge script, and with NCL, with less than one-page script, you can do it easily. And so for making beautiful 2D plots, NCL is the program. And how does it work? It has the command line. So if you type, I can do, for example, here. If you open a terminal and you type NCL, after installing, you can go and type the commands to start. Or you can just make a script, like a script that we make for MATLAB or for, I don't know which language do you use, but you create a script that you load external functions, you load files, load already existing, you load the libraries, and then you begin and end your script, and here you create the what you want to do. So open an input file, open a graphic output. I'll show you, for example, I'll show you later. But I think it's nice to come back to NCL and we work a little bit more with that. And so with a few lines of code, you can build an amazing graphic and maps that it will be extremely hard with other packages. So yeah, I really recommend you to learn, if you don't, this NCL command to work with WRF model. And another, I'll come back later with this NCL because I think it's something it's important to pay attention on it. We have there is this software called Vapor. It's a tool for animation. What means Vapor? Vapor means visualization and analysis platform for ocean, atmosphere, and solar researchers. So it's a software built for, basically it was built for analyzing models data. So you can make 3D animations with the WRF output, for example. And it was also developed by the WRF team. And so it reads the WRF output. It's wonderful for, like, for example, you have a hurricane and you want to see the 3D cross sections of a hurricane and like make a flight on the hurricane. You can make it with this Vapor. They have tutorials in their web page. So you just go there. It's again from the ucar.edu. Vapor. If you type Vapor WRF in the Google, you'll find this page. And then they have this training part that you can go and work on the tutorials. You just download the data and you can, for example, make the tutorial for visualizing the Katrina. And so it's a tutorial for visualizing hurricane. And if you have a hurricane here in the Indian and you want to, you can do the tutorial using your data, for example. And then it's like you can self-learn this machine, this tool, and make it. I really recommend you to do at least once in your life, because it's like when I saw for the first time, if you go on this web page, they have like here in the home, they show what you can do, and it's really can do really professional output analysis with in half an hour you can do a wonderful 3D animation. And again, it also can couple with NCL and WRF. It works if you know how to work with NCL, you can use both together to do even better animations. Another tool which was not created for WRF, but like the NCL and Vapor, they are based, the users are WRF users. But there is this grads. Nowadays, people are switching to NCL, the grads user. So I think the development page from grads, they stopped the development. But it's still a nice tool for fast visualization. It's better than NCView, but it is worse, let's put it in this way, than NCL to make a beautiful graphic. But if you just want to see your domain and how is your domain, not for presenting, but just for yourself, it's easier than NCL. So it's what means grads. Grads mean grid analysis and display system. So you open the NetCDF file from WRF output, and you can see which variables and plot the variables really fast. So, for example, we can make these graphics. They are beautiful graphics, but NCL does better. But we can do this graph with only 3 lines or 4 lines of comments. And for example, see where is your grid. So plot the grid and see where is the inner grid, and make a trajectory of something like a ship or a hurricane or whatever you want. And so, for example, this will create this image. So I just open the grads, and then it opens, and then I type open the file, WRF output. I just open. Something important here, the grads, it doesn't read the NetCDF file from the WRF output. You have to run the ARW post, which is, if you remember that first, the WRF has the WPS, the code module, and the post-processing, it has the RW post. ARW post, it will create this CTL file, and grads reads this CTL file. The CTL file is a text file that tells the grads what has inside the binary file from the WRF. So you just open the CTL file, and then you make only a few, like set map high resolution to get a high resolution map, set GX out shaded to make a shaded plot, and then, for example, plot the U and V arrows, and you just D display, and skip 20, otherwise it would be a mess, and U and V. And then display the nest position, and then it display where is the, and then open a second file and display the SST. So only with 1, 2, 3, 4, 5, 6, 7 comments, I created a nice picture for visualizing something. And so it's straightforward. I think for me it's better than NC View, which sometimes with NC View it's hard to make a plot, but it's easier than NCL. You don't need to build a script to see a easy plot. And well, these are the softwares for 2D and 3D visualizations that we most use. And sometimes you have to play with the code. So let's, with the NetCDF file. So you have, for example, 2 grids, and you want to merge them into the same grid resolution, and you need to work with these NetCDF files. Then the NCL and grads, you can do it with them, but then sometimes it's hard. And this CDO program, it helps you really fast with a few lines. So what means CDO? CDO, it's climate data operators. It was made in the Max Planck Institute. And it's a collection of command line operators that support GRIB, the GRIB 1, GRIB 2, and NetCDF, the version 3 and 4. And nowadays, the WRF works with NetCDF 4. So if you want to compile WRF, you have to have installed in your machine the NetCDF 4 to, if you don't have, you cannot have the outputs, anything. And support other types of binary files. And it has more than 600 available operators. So for example, you can sum, you have a variable in one NetCDF, you have another variable in another NetCDF file. You can sum these two to create a third file with only one variable, which is the sum of the others. You can calculate, make statistics like EOF, and normally EOF is something that if you write a script in Fortran to calculate EOF, it will be a huge script. In CDO, you do it with one command line. And so it's something that helps. Like for me, I usually use CDO when I have no idea how to do something, and then I type in Google the solution with CDO. And usually there is a solution there to fix the problem. And it has a very active forum that people send their problems there, and people from who created CDO, they answer you if not in the same day, in the same week, they give you the solution. So how does it work? It's a command line, so it doesn't have any, you don't use the mouse to click. You have to open in the terminal, and then you type CDO. One option, like, I'll give you an example. Then the type of operator and all the other operators. So for example, I have a binary file with SST that I created using Fortran or NCL or another file. But I created this binary file, and it's I created, and WRF is not reading this file. So I want the WRF to read with the WPS for example, my SST file. I created a sea surface temperature file, and I want worth to use this SST file instead of the default from the GFS, for example. And how do I do it? If I wrote a simple binary and the worth only read the grib2 files. So a solution can be, I use the grads to create a grib file version 1, and then I use the CDO to convert to grib2 file. It will convert from grib1 to grib2, or you wrote a .mc file. You can use the CDO to convert from NetCDF to grib2 file. With only one command line, it will create your SST new grib2. And sometimes it creates wrong, and you make another command to fix. This you can find in the forum. Or an easier example, if you have two files, one file on NetCDF and a second file with different grid resolutions. For example, I run worth with 9 kilometer resolution, and I have an output. And then I run with 3 kilometer resolution, I have also an output, and I want to compare them. To open in grads, for example, if you want to compare two files, you have to have both in the same grid resolution. So you have to convert, for example, the file 1 in the same resolution as the file 2. With CDO, you do in one command line, like remapbuild file 1, and then file 2, and the result will be the file 1 in the resolution of the file 2. You have a third file with the same resolution. So this is very useful. And there are other thousands of examples in the web page. So if you have a problem that you don't know how to solve it using things that you know, remember that CDO, it's a tool that you can use it. And all these tools that I'm giving you, they are all open source. So it's available there. Just need to download and use it. There is another language. I have never used this tool, but it's similar to the CDO. It's NCO, which is NetCDF operator. The CDO is more for all kinds of files, grib1, grib2, so you can work with all kinds of files. This NCO is more for NetCDF files. So if you have a lot of worth output is in NetCDF file. Sometimes it's good to use NCO instead of CDO. Both do basically the same, but I heard that for worth NetCDF files input and output files, and make that same example that I did with CDO, I told you with CDO, like the regrid, it can also be done with NCO. And I also heard that NCO is more robust. So it's good to know that these two exist. So if you have a problem and don't know how to solve, go on in NCO web page or in the CDO. Like nowadays, people develop a lot of things, and usually they are available. it's useful for you to know that they exist, and don't spend like 1 month trying to solve something that you can solve with one command line. You just need to know that these things exist and go to the right place to search. Know the right words to tell on Google. And so for a summary of these softwares, if I can make a summary, so basically the NCL, Vapor, Grad, CDO, and NCO. And the advantage for each one is NCL, it's good for a 2D graphic, Vapor for 3D graphics and animations, Grads you can use for quick visualization of your domain, and CDO and NCO for manipulations of files. If it's a NetCDF file, NCO is the best, but it's a file that it's not NetCDF, it's a file that you created by your hand. So CDO, it's a good software for you to use and manipulate with them. And there are other programs for post-processing, like DR, Python, MATLAB. In my university, we learn C++. And you can work with the NetCDF files using these programs. MATLAB, you easily open NetCDF file too, but they were not developed for atmospheric science. So let's put it this way, the world is bigger than, for example, the NCL world. So the NCL toolkits, they were developed for visualizing model outputs. And these ones are for visualizing things, biology, science, up to, we can also work with models here, but they were not created for that. So sometimes you will spend 1 month to create a script in Python to make something that with NCL you can do in 10 minutes. You do the same thing that you spend 1 month in MATLAB. And so if I could say a message, which software is the best? The best software is the one that faster solves your problem and providing a fancy and confident result. So, for example, for me, Grads is the one that I faster visualize a result. For Olafur, he can use the NCL, he do it faster. So for him, NCL will be the best. But the important is for you to know that all of these tools, they exist and you can play with them. So yeah, this was I'm planning to present. And I think we can go for some example of NCL just to give you examples. Could you download? So I already have the eWorf. Yeah. So on this eWorf is a Linux that you can virtualize in your Windows machine. So. And it was developed from a professor in University of Bergen in Norway, and it already have the NCL, and most of the software is already installed, and it also has some WRF outputs for us to give you examples. And while you pass, I'll show you the examples from NCL. I don't know how comfortable are you with the Linux command line. If you know, have you ever used Linux here? Who has ever used Linux? Yeah, we only have two. I think I could give you like a short introduction about Linux too. It would be nice for you to. Yeah, because if you want to run WRF, you have to know at least some basic commands and how is a Linux. So, well, once you install Linux, you have at least the Ubuntu, which is Linux is an operational system. We have a lot of kinds of Linux. So maybe I'm not the best person to talk about this, but for example, you have Windows, we have Mac, and we have kinds of Linux, which is a Unix platform. And for example, I like the Ubuntu. People like Fedora, Red Hat. They are other kinds of operational system. And WRF runs well in Ubuntu. So if you want to install the WRF in your machine or in your where you want to run WRF, it's good to have Ubuntu. Yeah. So Ubuntu, the latest long-term service version, which is the 12.04. It's the best one to install WRF. A professor asked me, he has a Sun system, and it was not working the WRF, and the solution is switch to Ubuntu. It's quite easy to install and work. So if you are going to work with modeling, I highly recommend you to install Ubuntu. You can install like we're giving to you this virtual machine, and so you copy the files, and when you have this, but with another cover and background.
There's asking to put the password, but I don't know the password.
The password is 129. 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost sure. If not, there is a 0 afterwards, or in the beginning. Work? It works. So yeah, when asked for a password, is 1, 2, 3, 4, 5 up to 9. Easy password. And then you can, if it doesn't, I think it doesn't have the terminal here. So if you go click in here and search for terminal, you'll find a terminal. And in Linux, we use a lot the terminal. And there are a few commands that you have to know to start. The commands are list, ls, will list what you have in that directory. mkdir, which is make a directory. So you can make a directory called test1, test2. Oh, sorry, it's not. So you create, and then you call list. You create this directory test2. Another command important is remove. So you want to remove that directory or remove a file, rm -r, R, it means that it's a directory. So remove the directory test2 that I created before, and now it removed there is no more test2 here. And another command important is cp, which is copy, and for working with opening files, yeah, I think we can go through the Michel course, you'll have more examples. But if you want to write in for a fast look, I think these are the commands that you have to know to start working with Linux. So I installed the eWRF here. We can go on the eWRF and we play there. So when you install your eWRF and open your virtual machine, you have a page like this, right? And like for example, I have the Windows in a virtual machine here, so I have one extra, but you will have this eWRF. So for who have already installed, if you make a double click on here and start, we'll start the eWRF. And while it loads, I'll open also the Michel Mesquita's lecture and we can go through it, right? So there is a web course that was created by the guy who created this eWRF, and it's a web course that at least we expect to do, but we can do here. If you go type in Google M2Lab, this one. Yeah, right on the side, because if you have time tonight, or we will go through the presentations in this eWRF to explain you better how the WRF works. So you just go in this webpage, www.m2lab.org/ don't need a slash, just go there. It will open a page like this. And if it's your first time, you have to create a new account, and then you can start. But then I already have. We'll go on it. Yeah. Well, the first tutorial, because it has in Portuguese, French, and English nowadays. Mine is in Portuguese, but I'll find the one in English here. Yeah, we here in this course we will make in the afternoons this introduction to WRF modeling system. So Michel created Dr. Michel created this web course, And in this course, it goes through the WRF and explain how to run and how to play with WRF. And it has a forum and some news. And let's go to the part. The first part of the course is the preparation. So it's obtaining the eWRF that we are passing here, and then you will download the eWRF. If you cannot download today or something goes wrong today, tonight I think it's good for you to go inside here, make a login, and obtain the eWRF. If you click here, it explains you how to download this file that I'm passing to you. It is a 4 gigabyte file. And then the first activity is to download the eWRF. And the second activity, let's go. And I'll use this course to explain you the NCL and the Linux commands. So I think this is just to prepare you to the eWRF. That is the next. So it will explain you how to use the VirtualBox using Ubuntu and setting up the Linux and making a plot with NCView. Oh, let's go there. So it will download the 4 gigabytes file. If you unzip the file, it will be 12 gigabytes. Something I didn't tell you. When you created the virtual machine, it will ask you how much memory you want to reserve for your virtual machine. I would recommend you at least 2 gigabytes. So, because less than 2, it will take a lot of time to run the WRF, or run a quite easy example. So when you're setting up your virtual machine, please set. If your laptop has 8 gigabytes of RAM, you can set up to 4 gigabytes. If it has only 4, set up with 2. If it has less than 4 gigabytes, then look to work with another person. But at least 2 gigabytes of RAM memory. And so you will download the virtual machine. So this from Oracle. And then it's easy to go there. I think we can skip this part. When you choose, you create a name, for example, eWRF. You choose the type of the machine will be Linux, and the version is Ubuntu. Is the type of the Linux. And set up at least 2,000 megabytes, 2 gigabytes of RAM memory. And then when it asks for the hard drive, the default is create a virtual hard drive now. Don't go in the default. Use an existing hard drive file, which is the one we are passing here. And then use this core ubuntu.vdi. Okay. And then you have a system like that one that I show you. So, for example, this one, and then you just go WRF, and will come a machine like this. So then you have the Linux in your computer, and then we can start make anything. And let's come back there to the WRF presentations. Setting up the WRF. And then we are finished. So if everything goes right, we are finished with the WRF. Who here has already this part installed? Nobody, right? It's working on yours. If the Mac is working, and it's passing here the I think in the beginning now, while nobody has, I'll try to explain here on the data show, and who has, I think it's a good opportunity for you to do it on your own laptop. So if we go on the here, no, this is my machine. I have to take care which one is each machine. So if you open a terminal, it will open something like this, probably in a black window. I don't like to work in a black window, it makes me scared. So if you go here in view, no, not this view, in edit, profile preference, you can change your background color to someone that you like more. Then it's better, it's not that black window. But that black window is the black window. And then, and here it's easier to see. If you go here, in this WRF, it already have the WRF installed. So let's take a look on the WRF. CD WRF. In this file WRF, look, it has the NetCDF 3. So it was compiled. I told you we need at least the 4, but the 4 I think is the new version of WRF. This version of WRF I think is the 3.2, which is like from 2 or 3 years ago. So if you want to read, let's take a look in the read. There is in Linux, there is a VI for editing files, or VIM. It has we can see in the terminal what's written there. So has an introduction that Michel prepared, but he didn't tell here which kind of WRF. But anyway. The VI is another command that you will use a lot. VI or Vim. I like Vim, which is the newest one. If it doesn't have, you just download it. You can go on the terminal and see what is inside that file and make changes. If you want to make changes, you press the insert button, you can insert and write something there inside. So you click insert in your keyboard and write something. To save, you press ask, then you get out of, and W, it's say S, double points. I don't know what it is.
Is it better to use G edit?
or gedit. I'm not sure if they have gedit there. Yeah. Pay attention one thing. This Ubuntu is setting with English keyboard. So my keyboard is in Portuguese. So where is the double point?
Next to L.
Next to L. So. Yeah, double point. W is save. Key is exit. So if you open that again, I save it with that strange lines somewhere there. Well. And key is just exit. I'm not sure if we have a gedit here. Maybe you have. Yeah, it has too. You open with gedit. Gedit, it's like the note from the Windows. And then we can go. So let's take a look here in the WRF directory. We have the two directories, the WPS and the WRF v3. The WPS is where we have the preprocessor system. So if you go there, WPS. I'm not sure if I told you, CD is change directory. So it's another command that you use a lot. So change directory to WPS. On the Linux, if you make a double click, select, and you press the middle button of here, it copy and paste. So you can make it easy. Or if you write part of a word, like GeoGrid, and I press tab, it show me the options. So once, like if I say gedit, it will fill with gedit. If it has more and I make it twice, it will show you all of them. But here we have the file, the parts that Olaf explained during the first lecture in the preprocessor system. We have the GeoGrid, the MetGrid, ungrib, and MetGrid. These are the three folders that we have, and the three executable that we have to execute to make the preprocessor of the WRF. Olaf would explain you short. Maybe I should explain slowly again. Yeah, what has within each one. So GeoGrid will create your domain. So for example, we have here, you create a domain, and GeoGrid will create the terrain, the surface, and you will create your domain. The ungrip will prepare your input data. For example, we download from the GFS a data, and then with ungrip, that file from the GFS, the ungrip will read that file and interpolate that file to your grid created here in GeoGrid. So to run the ungrip, you have to first run the GeoGrid. So GeoGrid creates your grid. ungrip will get your file, your input file, and interpolate that file to the GeoGrid. And then you use the NetGrid to merge both together and create your input data in the WRF grid for WRF read it. So let's make an example. I'm thinking, I'm following this tutorial. It's this what we are going to do now. So the first activity, we went to the WRF, and I think we can do it later, but going on the conclusions. Experiment design. This one. Here we will make an example. I think we could make a grid for Seychelles and explain how to make it easy. I think we can do it in 1 hour. Can I? Yeah. And I think it's a good to, yeah. So
just one quick question. I just wanted to see if the participants are on the same page. Just to make sure.
Yeah, maybe I go too fast.
No, just to see the link.
If it's loaded, you downloaded the link to have the eWorld.
Yeah, I think, yeah, you go trying to install, I'll present here, and you try to somehow pay attention here, and then you try to reproduce again. It's maybe important for you to take a note, a few examples, and you can do it maybe later alone.
Yeah, I was wondering the Linux, whether everybody is used to Linux.
Yeah, you will not learn like in half an hour. You have to play with it. It's like math. You cannot teach math to a kid. But after playing with that, it becomes really easy. But I think we have, just take a note of these few comments, what each one, like when I started programming with Linux in like 10 years ago, but I was already old. I was finishing the university, and for me it was something completely new. In the beginning I was really slow, but if you have in your notes on side, you go there. After using 10 times, it's in your head. You don't need that note anymore.
So how many have downloaded the eWorld from the portable disk?
I'm still downloading.
So one.
Yeah, you both have, no?
Yeah.
You download and you look with him. He also has. And I'll try to put on the, and I think I will create the name list for them, and then I will share again.
Yeah, you can share it either later today or
tomorrow. We make a mail list, and what we create here, I share with you, and then you have, and tomorrow in the afternoon we go to the next step. And on the afternoons we do something like this.
I think if at the end of the day everybody has eWorld, maybe gone over the GeoGrid steps.
Yeah, the WPS.
Everybody will go through this exercise again and then continue.
Yeah, I think today we can go through the WPS, tomorrow through the WRF. WRF part is quite easy. I mean, we can talk about the.
Everybody has eWorld.
Yeah. And we finish this WPS part now, today.
Not necessarily. We can introduce it and then do the hands-on.
Hands-on.
Put it together tomorrow.
Yeah. So let's make this example of creating a grid for Seychelles. Do we have a pen? No, for here. Because then I can make some notes here. If we have a big pen. I'll write. I have my pen.
Yes, for the...
Yeah, and then I'll try to write big here with something that we will probably need. So when you are going to create a grid, you first need to know where you are going to create your grid. So I like this web page lat long. You type lat long in the Google and you will find this iTouch map. It's a really nice web page for download, looking at latitudes and longitudes. Good. And then we will make a grid for Seychelles. First thing you will have to know is Seychelles. Actually, I cannot see here. Yeah. Here is Seychelles. We click, and then you write in your paper where we want to make our grid. So lat minus. We don't use the degrees, we need to use the decimal, and that's why this web page is nice, because it gives everything to you once. So minus 4.68. Okay. Sorry for my letter, because 5.5. 4.68. Right? So we will create a domain for Seychelles. Okay. So the first thing we need to do is the WPS, it works with a name list. So we will open this name list, which is this file here. Let's open with gedit. A nice command, if I make like this, it will block my terminal here, and I cannot work. Unless you type Ctrl-Z and BG, but then you can type jet and put the commercial E. I think this letter is commercial E, at least in Portuguese, afterwards, and will not block your terminal. It's another tip. Then here I can still working on the terminal, and I have the gedit name list here open. And this is the name lists. They are divided in blocks. How is each block? We have each block starts with the commercial E and finish with the slash. So this is a block share that will share between GeoGrid, UNGrid, and NetGrid. This is the block for the GeoGrid. This is the block for UNGrid, and this is the block for NetGrid. So on the block share, we have to tell WRF which core are we going to use. We are going to use the core ARW, which is the core for numerical predictions. You could use, the WRF has also the core NMM, which is for hydrostatic, not?
NMM is non-hydrostatic mixological model.
Yeah, anyway, we always use the ARW for most of things we do. So we never change this. Here is the max domain. So the number of domains we will create. So we can make only one nest, so we set it to 1. If we want to make 2 nests, then I set 2. If I want to make 3 nests, then I set 3. Here is your start date from your input files, and so if it's 2, as Olaf told, you have to make 2 columns. If it's 3, will be 3 columns. And the end date is when it finishes. And interval in seconds is the interval between the input files. And this I/O form is 2. It means it will create a NetCDF file, basically. I will, let's see. I think we have already an example of input file here. I'm not sure where. Data, probably is here in data. Now, when I say ls is list, // is in the parent director, in the parent director. There was data. ABC probably is lateral boundary conditions. Norgis. Yeah. Here we have the files from the GFS for 2016. Oh, no. So to make an example, here we'll work with this. Maybe tomorrow I can download another example. I'm not sure if this file are global to make an example for us. Let's see right here our start date. 2008. 08/04/25/00 goes to 2008 04. Let's make an example of 6/26. Let's run only 1 day of forecast going to 00. It will pass through the 06 and 0 and 12 and 18. So let's make our simulation start on 2008, in April 2008, 25th, 00, and finish on the 26th. I think it's important to teach you where to download this input data. I think it's something Yeah. Where to download it? If you want to download the GFS data, go to this. It's not this. Yeah, just a second. Let's. This is a script I created for downloading this data automatically. So you just get the data, the date, and you get the hour, you set some conditions, and then you go to the web page, which is this one. And this shell, it's a command for downloading. So if you type, and then I have, so if we go to this web page, copy and paste here. Yeah, so write this. It's important for you to write, because you will need this like a lot. Can you see?
No, you can't see.
I'll make it bigger. It's here.
Can you put it somewhere on the internet so they can copy it?
Yeah,
The link.
Maybe I should send via email. Can you write everything that we have to send? Yeah, I can send you the link afterwards. But yeah, it's here, ftp.ncap.noaa.gov/pub/data/nccf/com/gfs/prod. If you go on this web page, something important, this web page has only the newest files. So they store for, I think, a couple of days, like 5 days. If you need past data, then there is another web page. I send you later this other web page, but it's from Nomads. But then you come here in this page, GFS and the day. So today is 2016, 23rd. Yeah. They still don't have, here, 23rd. So February 02, 23rd, and they already have from the 00, and also from the 06. If you go to the 00, then they have these files. And the file that you have to download, because it's good for you to take a note, because they have thousands of files there. And the important for you to download are these .t00 is the name of when it started, and forecast 03, 04, no, it's not this one. Yeah, let's go there in that script. You have to go to the file, look, see the date, and the file is the one gfs.t, the hour, for example, 00, and .pgrb2.0p50, and the forecast, the time, like, so pgrb2.
Isn't the link
These ones.
on the M2 lab? in the tutorial.
Is it there?
Yeah, I think so.
Yeah.
If you send it to me by email, I can put it on the internet, on the my website, so everybody can just copy it.
Copy. Yeah. Anyway, I think we don't need them now, but like are these files PG, see PG 0P25. P25 means 0.25 degrees of resolution. P50 is 0.50 degrees of resolution, so you can choose which resolution you want. The best one is the 25, but they are huge files. You see, it's this 193 megabytes of file. For the analysis is 170 megabytes. The forecast, the forecast is 193, and the 210. If you want to make one-day forecast, you will need to download the 0, the 3, the 6, the 9, and so on until the next 0. So then you can make a count of how much you want. And yeah, I can give you also this script. I think we can go on this script too, just for you to see how okay. Oh, it was the opposite. Sorry. It's now it's better to see. So how was this script? This is a bash script. So in Linux, if you want to make a script, you use we call shell language. So you have to code in shell, and the script always start with this. I don't know the name of this in English, but this an exclamation /bin/sh. You can define some variables. So I define variable directory on my WRF folder, and I call dados is data in Portuguese. So I created a folder for putting the data, and then the name. I defined other variables to get the year of now, to get the month, the date, and how many hours of how many files I want. And then I create a directory and cd change to that directory. And then I make a for loop. If you programming, we need loops to make interactions. And in shell script, a loop, you start with, it's a for, and you have to finish this for with a done. So you start with a for, you finish with a done. And then you have the name of the file, that file gfs the hour that start that I defined it first, which was 00, PGR, and F. This is the time, which I defined here for this in sequence from 0 to 3 with 3 digits until the last one, which I defined it first, do the loop. And then it tests the size of the file, if it exists, or if it's less than a limit that I decided, it will download. If not, and here it makes some tests, but With a file like this, you can download I can give you this shell script later. It is in Portuguese, I can translate to English, but it downloads the GFS file. You just have to set your directory here instead of the directory I create, you put a directory that you have. Let's come back there. But anyway, here we have the files. I think we can download a few of them for today. So let's make a dir GFS, okay? Have a file GFS, and let's download this a file from today. And while I give you the class, it go downloading. wget cd GFS. That Excel, I don't think it works here. Yeah, it doesn't work, but you can use wget. Wget will download. It's not that robust as Excel, but it also works. So download this GFS. Oh, not working. Oh, it's on top. FTP. //
Try to use Ctrl-Shift.
Yeah, because it's other machine.
It cannot copy Ctrl-Shift and C.
Sometimes it works, but I think I should set up something here. I copy. Here. You see, don't have the paste because it's not interacting. So I think I have to ftpp c.n set dot gov /pub /data /nc